Um, on mine, it says, on my video, it says, click to disable video. So it seems like it's on.
Try that again. Just click on that and see what happens.
All right, I'll click on it.
That's what it looks like, is that you just muted.
Yeah. It says camera is turned off. You're not sending your video. Now I'm going to click again and it should be enabled.
That's the video from your webcam, not any content that you might be sharing?
No, that's right. It's just my webcam.
Okay. And I do see the flashing red dot that indicates we're recording.
Okay. Remind me of your name. I'm sorry, I forgot.
This is Steve.
My name is Simone.
Simone.
I'm here at Canterbury, the tech person.
Simone at Canterbury and Steve at Fort Worth.
Simone, are you getting his video feed?
I'm seeing him. I'm seeing two people on the screen right now, and it keeps swapping back and forth based on who's talking.
All right.
Or two feeds, 3 people.
Okay. There's a way to get constant presence, but is that only in Adobe Connect?
It should be in BlueJeans.
Okay. I don't remember how to do that.
Are you the administrator?
Yeah,
you would be if the recording started.
Yeah.
I believe on the right,
near
the bottom of the
settings
sidebar, there is one of those buttons brings up the option to choose the classroom layout and to apply it to everybody.
Okay. Oh yeah, here it is. Yeah, so I'm going to do constant presence. Okay. All right. So constant presence should mean that we're all here. Okay. Let's start.
Working on it, guys.
All right. I want you guys to take the quiz.
Okay.
Which is on eCollege, quiz 2.
Okay.
All right. It'll take 5 minutes or so.
Hello. Hello. Hi, Ken. As far as I know.
Oh, and the password. The password is Axiom, A-X-I-O-M.
Okay.
Small letters. A-X-I-O-M.
Are you able to log in?
Yeah.
I don't understand. I'm not getting video.
He never showed up today, though. We haven't seen him yet. I don't know if my thing let go or if I'm not.
No. I mean, I've got it over here.
What was the Axiom?
Axiom?
Axiom.
A-X-I-O-M.
Oh, thank you.
Sure. Small letters. That should work.
should be over. I'm gonna hang up on you guys one more time.
FBI.
Roll down the window. Roll.
I'd like each of you to let me know when you're finished.
Okay.
Well, I finished.
Thank you, Walter. Walter, while you're waiting, I put 2 files in the classwork for today. January 23rd classwork in DocShare. You can look at those because we're going to talk about those next. Ryan and Logan, I'm going to give you 1 more minute, and I'm going to give you both an opportunity to retake later. Okay?
Yeah. Okay.
I'm done.
Yeah, me too.
Yeah.
All right. Good. Okay. First, I want to talk about homework procedure because I have an idea. So what I did with your homework was I used the review tab in Word, and I started making comments, but then I just realized I just wanted to type. What's happening?
We're just closing the door.
Yeah.
Oh, I see. Okay. Got it. Thanks. And then I thought, well, especially Ryan, there were, you made a lot of errors, which is to be expected. But I thought in general that here's my suggestion. After I review it and and I make what I'd like you to do every time is go over it again and correct your errors. And if you want to add comments, that's fine, and then resubmit it. Because I think that would be a good learning tool. So, you guys agree?
Yeah.
Walter, is that okay?
Yeah, sure.
Okay, good. So let's do that. So that'll be part of the homework. I'll put that in there. I did forget to put the composing transformations file on DocShare, so I'll assign it this time. So don't worry about that. Okay, I want you to go into Adobe Connect Friday room, which is the one that starts with, hopefully you bookmarked it.
Mhm.
Okay, and I am going to go into wait a second. Yeah, here it is. I'm going to share my screen. I thought I did that, but I'm going to reopen it because I think I had a problem. So, there. Close this. Okay, and now I'm going to share my screen. And then I'm going to go to Word. Okay, so the question is, can you see I have I have the topic list up.
No.
No. Okay. Okay, I'm going to share my screen through BlueJeans and see if that helps. Did that help?
Yeah.
Okay.
Yeah.
So that's what I have to do. Okay. So I also put these up on the in DocShare on today's class. So here are the topics. Yeah, unfortunately now I can't see you guys, which is what I wanted to do, but okay, figure it out. So the first three topics we said we would do, and then Walter in particular, I haven't heard from Logan, so at this point, leave it this way. Explore a so we're going to start doing number 4 here today, and especially today. And then nobody put this down, but it's quick and it really ties in well. It's like one class. So I guess I'm making an executive decision. I really want to do this. And Ryan wanted to do complex numbers, including their history. And so Walter wasn't crazy about that, but one of you did. So I'm trying to kind of alternate. So yeah, so I want to do some of this. And then next, Walter wanted to do 3D Euclidean, including 3D symmetry. And that's a good one too. So I want to do that. And then geometric probability is also, Ryan put this down, and that also is quick. At most one class, and it can be spread out in the homework. So we might as well do that. So that's the first few topics, okay? So I just want to let you guys know that. Fair enough? Okay.
Yeah.
All right. So let's see. Yeah, I need Word here. So I want to close that. Close. Okay. I also, yeah, so we're not going to do that. Okay. And then we're going to talk about definitions, and I also put this up. But before we do that, Ryan and Logan, especially Logan, we need to make a time to catch you guys up, because we just need that. Is that so? Can you guys make some suggestions? Not right now, but in an email to me about what times you're available. If you want to do it both together, that's okay. If you want to do it separately, that's okay too. You know, you decide. And yeah, so we really need to do that soon and make a schedule. Yeah, especially Logan, because it was really hard because, you know, you joined late and then you got sick. So that's like 2 weeks worth of stuff. So yeah, and we can use the Blue Jeans room so to meet. So it turns out that that's always available. So all right, fair enough, both you guys. So I want to get an email from you by the end of today. Okay.
Okay.
About possible times. Good. Okay. So we are in line with the topic about, and this is really invention by us, because I don't see this anywhere. A transformational geometry axiomatic system, basically, is what we're going to try to do. And yeah, so let me think for a second. Yeah, I wanted to go over first. I'm going to go over the just look at the article from Axiomatic Systems in general, which is here. Okay, can you see that?
Yeah.
Yes.
So this was the reading, and this is the answer to the quiz here. These four, partial credit on that. But are there any questions or comments on this? Did this make sense to you?
Yeah, it made mostly sense.
Okay. All right, good. So it's a matter of you know, how we want to do this, and there are there are two conflicting kind of poles. One is when we make an axiomatic system, we want to avoid pointless proofs or obvious proofs if we can, to some degree, right? I mean, what was your I guess that's my question. What was your geometry course like? Was it, you know, was it Euclidean in this sense that you eventually you made assumptions and you proved things from those, and you proved things like if two sides of a triangle are equal, then opposite angles are equal and stuff like that? The really obvious stuff, and vertical angles are equal, or did you just assume those things?
I think we
proved it.
Okay. Walter, you too?
Yeah.
Okay. Most students kind of, you know, get really bored by that. I mean, there's a great quote that I saw at one point by a student who said, "My teacher just spent all period proving that the base angles of an isosceles triangle are equal, and I knew that already without all that trouble." Did you kind of feel that way?
Not really.
Yeah,
No.
a little bit sometimes, but most of the time I was pretty intrigued.
Okay, good. So there's the tension between that feeling and wanting to make a really
It's a
tight.
30-second proof.
It's a 30-second proof. Okay. Yeah, but for some students, it's not a 30-second proof. It you know, you're very good, but for some students, it's harder than that. And on the other hand, we want to make a tight logical system. And I think, and you guys being really good math students, you probably are more into that than others. So there's that balance that we want to bear in mind. So with that in mind, I'm going to go to the definitions sheet here. Okay, and some of these, what's in blue on this sheet, is from that the document that Henry wrote. My friend Henry Kitchen. Can you see that?
Mm-hmm.
Yeah.
So these blue ones are the definitions that are made. We don't have to use those. We can make something else. So we're going to discuss the definitions. Okay. So what's a transformation? Well, one thing I said is this, and this is what Henry said. What do you want for our definition of a transformation?
I mean, they're equivalent.
Yeah.
I guess the shorter one would be the preferable one. What about you? What would you think, Walter?
Oh, sure.
Okay. So we'll go with that. This is going to be our official list here. Okay. Here's isometry. This is mine. This is Henry's. Do we care? What do you say?
The shorter one?
Okay.
Yeah, the shorter one.
All right. I guess
They say the same thing.
Yeah. One difference is that he starts with the word is, and I just made the word and then the definition. Okay. Now reflection, you guys did. So this is what Ryan said. Right here, you can read that. Okay. And Walter said this. Walter tends to be, he has a lot of mathematical sophistication when he writes, possibly from the last, the fall course you took, right? Where I think that was really an important part of it. And by these absolute value signs, you mean distance, right? Walter, is that your usual definitions, that if it has the absolute value signs, it means distance, and if it doesn't, it means the segment?
Yeah.
Okay. And then this is an important part that Walter put in here. It has to be different if the point is on the line. So another interesting thing is that there are kind of two types of definitions sometimes. There's a constructive type, which tells you how to do it, and Ryan's is kind of along that line. And then there's a descriptive type, which says just, here are the conditions. And I think Walter's a little more like that. They're both long. There's a really short one that Henry did, which you did see, which is this. Using the idea of perpendicular bisector to just get both of these ideas quickly. So I was thinking that we could do something like this. What do you think of this? If A prime is not on line L, then A prime is the reflection of A in line L if what?
If L is the perpendicular bisector of A prime.
And I'll fix this up, make it look nice. And then if A prime is on line L, then Ryan or Logan, what do you say? If the point, I'm sorry. Yeah. I'm sorry. This should be A, not A prime. if A is not on line L, and then if A is on line L, then what?
What Walter had bolded in his definition.
Yeah. How do we just say that? Really in symbols, shortly. What is A prime going to be?
A.
Yeah.
Yeah.
Like that. Okay? So how does that sound to you guys? You okay with that?
Yeah.
All right. Let's get rid of this. This is going to be our official list here. And I will share it. Okay. A vector was not defined. So what is a vector? Vector AB is what? How should we define that? Or should it be undefined? Should it be an undefined term? Don't all talk at once.
What are the undefined terms that we have?
Well, for Euclid, it was just like point and line, I think.
Then, okay. Oh no. Oh, it's hard to specify direction and distance.
Can we? Yeah, it's true. Precisely. You want to leave that one? Come back to it? Think about it?
Yeah.
Okay.
Yeah.
All right. So let's think about that. All right. Translation. Ryan said this. P is moved along a line parallel to vector u. It was u in the same distance and all other points. Yeah, that's a reference to all the other points, but I guess my comment was, how's the distance determined and what is the direction? And then Walter said, let P prime be the image of P. I just added this, to make it clearer. Then the vector is the same as the vector u, in essence. So, and then he writes, really the way we think about it, which is here. Okay? So, what should we do here? What do you guys think? Come on. Yeah. Yes?
It doesn't really matter which definition, as long as it's clear and I don't know. I feel like my definition is pretty good. So
Yeah. Okay. So how can we just state that? So then
if
okay.
if the vector A prime is the same as V.
Okay. Okay. Fine. Sure. Equals V. Yeah. And I'll fix that up. Fair enough. I mean, that seems good to me.
Yeah, that makes sense. Yeah.
Does that make sense?
Yeah.
So the key thing is to define vector. So we'll come back to that. All right, we got that. It's all happening. Oops. We can come back and modify it if we want to, but I want to have a definition list that we can refer to. Okay, rotation. Ryan said this until it reaches angle A. I wasn't really What does that mean? And Walter said, let P prime be the image of P. Okay. Then this. Then the distances are the same, and the angle will be angle A, which is the angle. Okay. So in this case, I'm using D. So can we restate Walter's definition here using these letters? So A prime is a rotation of A around point P through an angle of D, and we're going to get rid of the direction problem by just saying D is greater than 0 if counterclockwise and less than 0 if clockwise. So Walter says that the distances are the same. So I'm just going to write PO. There's an interesting a notational issue that I'll talk about in a second. And angle, and I'll fix this up later.
We can't use O because it's not defined in your definition.
Ah, right. So yeah, so that's not what we mean. What do we mean?
Oh, if PA equals PA prime.
Thank you. And angle what?
P prime equals D.
Okay. Make sense? Good enough?
Yeah.
Say yes. Okay. All right. The notational issue, so I'll throw this out to you quickly. One way to do this, to do distance, is to say that if it doesn't have a segment bar over it, it means distance or length. It's a number. And if it does have a segment bar over it, then it means the geometric object. Another way to do it is if it doesn't have anything, it means the geometric object, and then you need to use these absolute value symbols to mean the distance. Right, Walter, which is the way you did it?
Yeah.
So, which do you want?
The second, because it's hard to put bars over on top of objects in Word.
Okay. Are you guys? You can use math type to do it, but it does take more effort. Ryan, Logan, what do you think?
Yeah, I think the second one, because didn't we use it for other ones as well?
Yeah, we have. Ryan did. Okay, so that'll be our notation. So I'm going to change. Well, so yeah, vector does need that thing over it, but otherwise we'll do it the way we did it here, and I'll use the angle symbol here. Okay, dilation. And the key thing is direction, and that came up with both you guys in a way. You know, we want our definition to work with a negative scale factor also. This is Henry's here. Which is long. Okay. So I want you guys to help me complete, last thing, this dilation definition. This is the last one we'll do today on this. So A prime is dilation of A from point P with scale factor K.
Oh, you have to specify K is not 0 first.
Okay, good point. So K is not equal to 0. Okay. If A prime and P are collinear. Okay. A prime and P are collinear. Okay.
And the length of A prime P is K times the length of AP.
Okay. I wonder if I can take yours here and just modify it. So the length of A prime P is K times the length of AP, right? Okay, and now what do we do? We're not finished.
Oh, and then you just take Henry's parentheses thing and then copy it over.
Oh, okay. Fair enough. Did I do that right? No. Go back here. There. Cut. Okay, I'll fix the. All right. Good. Fair enough. All right. Stretch and shear, I'm going to ask you to look up and think about for homework. We did that. Here's the definition of congruence from Henry, and I think we'll use that. And here's the definition of similarity. And a key thing that we still have to think about is a sequence of isometries and dilations. If we use that as our definition, it would be nice to show that, for example, we could always do the dilation first, right? One dilation, two things. One dilation is enough, and it could always be first. Because if we could show that, then that form would be okay for any for proving similarity anytime. In other words, that this is, we don't need all this. You see what I'm saying? Is that clear? I'm not sure I was.
Yeah.
Okay.
Did we didn't we kind of touch on that on the homework for today?
Yeah, we touched on thinking about it, but we haven't done it yet. Okay. So that's a challenge. That's I'm going to add that to the homework in terms of really thinking about how that can happen. And I don't know the answer. So some of these things, it's really important. Some of these things that I throw out to you guys, I haven't thought about yet. And they don't seem that easy to me. So we're discovering math together. And I'm going to ask Henry, if you guys come up with some interesting stuff, we're in the process, or we're going to start writing an ebook, and you're going to help. So I'll put your names in it, give you credit, okay, with whatever you come up with, because that's always an important thing to do. Okay, so that's our definitions, and I'll save it, and I'll put this file up. Here are the assumptions that we've made so far, and we're going to talk about the parallel postulate in a minute. But these come from, again, Henry's article. So there's the parallel postulate, and we'll talk about that. There's construction assumptions that he makes, which are different. Those are, and he uses those in the proof that you'll read for homework. So these are kind of obvious things that, but I don't think they can be proved. And then we're going to assume, this is brand new, in terms of when you took geometry, this was not one of the things that you did, that reflection preserves distance and angle measure. And we also need to assume that dilation preserves collinearity, I think, unless you guys can figure out how to prove it. Okay? So this is our tentative list of assumptions, and we're going to need to possibly add to these as we go along. Or take some away if we manage to prove them. Okay? Okay, fair enough. So I'm going to close this, and these are posted. Okay, now I'm going to go to some other stuff. So these are the postulates that Euclid used. And I can post these links. That's easy enough. So this was 300 BC. A straight line segment, you can draw a line through any 2 points. You can read them. Any straight line segment can be extended infinitely into a straight line. Given any straight line segment, a circle can be drawn. All right angles are congruent, and these all sound like, oh my, these are pretty obvious things. I don't know whether we want to state something like it. The fifth one, there was a lot of controversy on, because it's so much longer and so much Yeah, more complicated than the others. It says, if two lines are drawn which intersect the third line is what we call a transversal usually, right? In such a way that the sum of the interior angles on one side is less than two right angles, that is less than 180 degrees, then the two lines inevitably must intersect each other on that side of the transversal if extended far enough. Okay? That's what Euclid wrote in 300 BC. And people thought, oh my goodness, that's so complicated, we ought to be able to prove that. Is this familiar to you or not?
Yes. Yeah.
Okay, it is to Walter. Is it to Ryan and Logan?
I don't remember it.
Maybe a little bit.
Okay.
But
So this is good to know. So they tried to prove this, and there's a lot of interesting math that went into trying to prove it. But eventually, how do you show that something can't be proved? And the way it was done was to develop a consistent geometric system in which this was not true, but everything else was. So that proves, and that's called non-Euclidean geometry, that proves that this fifth postulate is independent of the others. You can't prove it from 1 through 4 and all the other things that Euclid did. Euclid tried not to use this when he wrote. He didn't use it until he absolutely had to, which is like Proposition 29 or something like that, because he really wanted to avoid it, but then he realized he just couldn't. Now this is really complicated. Playfair, and I don't remember what year, but he came up with this axiom: through any point in a line, and this is probably the one you used, through any point in a plane, there's at most one. That's interesting. At most one. Okay. So he's not saying there is any at all. Kind of interesting. There is at most one straight line parallel to a given straight line. This axiom is equivalent to the parallel postulate, which was, I believe, Euclid's. Let's see what that says. Yeah. So the parallel postulate is what Euclid said. That's what it's called anyway in this article. So that's interesting that these two things are equivalent. And so as a challenge, I'm going to put that on. Can you prove that these two things are equivalent? Walter, have you thought about that, or have you ever done this?
Proving that Playfair's and Euclid's are equivalent.
Yeah.
Well, I mean, Playfair's kind of implies that there can be zero parallel lines through a point, right?
It seems to, yeah. Which is strange. I'm not sure of that, because that's I'm not sure, because it seems to me like spherical. That's when there's no parallel lines, right? Spherical geometry.
Yeah.
So
does Playfair's hold in like all geometries, or is it limited to Euclidean?
Limited to Euclidean, I believe.
Then
so I'm not sure about the at most here.
I'm not.
Yeah. So I have to think of it. This is what Wolf from Math World says. You can't believe everything you read on the internet. So I have to. Both of us, we have to think about that some more. And let's come back to that next time. And I'm not sure whether there should be one and only one, or at most one. I'm not sure. But anyway, if it were one and only one, which makes more sense, could you prove that both of these are equivalent? That this one is equivalent to Euclid's? That's a challenge. So let's just leave that. Something to think about. All right. We got about 10 minutes left, and I want to do a GeoGebra thing. I want to show you one more thing in GeoGebra, which is here. Okay, so I'm going to open GeoGebra and go to Geometry and make a full screen. Okay. We haven't talked about a slider. And sliders, this is a slider here, and these are really interesting and useful. So let's see if I want to try to make a slider for any angle of rotation. So I think I have to do this first. I think I have to make the slider first. Rotation, I'm going to need a point. So here's a point, and let's show the label. All right, so there's point A. Watch this. All right, and here's a slider. And what I do, I believe, is I put this here, and I can make it on a number or an angle or an integer. And I want to make it an angle, alpha. And here you can adjust the minimum, maximum angle. Instead of making it from 0, why don't we make it, 0 to 360 is okay. And you can adjust the increment. As you can imagine, the increment, if the increment is large, then it's going to jump around. If the increment is smaller, it's going to be smoother. So let's make it 2 degrees. And we'll apply that. And what happens is you get this thing here. And that doesn't seem to be very useful at this point. But now we want to rotate a point. So we need another point. And I'll call it P. I think if you immediately type let me try something here just for a second. If I do a point here, hello, and just do this and right away type a capital Q, then you don't even have to rename. You can instantly make it. So that's useful. All right, so now I want the rotation tool. So that's here. No, it's not. It's here. Rotate around a point. And I have to select an object to rotate, then the center point, then the angle. Let's actually make, before I do that, actually, let's make a segment so we can actually see it better. Here. From here to here. Okay. And move this whole thing a little bit. There we go, in the middle of the screen. Okay, so now rotate around a point. What does it say? Select object, center point, then enter angle. Okay, so we're going to select object. I'm going to do both of these things. Well, no, let's just select P. Object and center point. I better start again. I don't want to make a mess. Okay. Object, center point, and then it gives me the choice of an angle. If you go here, I can pick the angle alpha, which is the same angle, and I don't want the 45 degrees that I had before, and counterclockwise is going to be positive, and I say okay. There. And let me do it to the segment too. So segment point alpha. This alpha here just gives me the template. I have to pick the angle. Okay. So now this slider, I have to go back here. Good. Why is it not doing it? Good. I don't know why it's not doing it. Did it when I did it last time. Walter, do you have a clue?
Let me try building it, I guess.
Mine's working.
Oh, I know why. I didn't make the angle. Hello. I didn't make the angle. Which is here. I have to make the angle. It has to know what it's talking about. So from here to here to here, and I have to rename the angle. And call it alpha. Yeah, didn't know it was alpha. There. All right. It says alpha 1. I have to make a new slider, I think. Sorry. Let's delete this. Sorry about that. Oh, now I deleted the angle. So what I have to do is actually make the angle. So we need a point here. We need a segment.
Oh. It's gnarly.
Watch the time. And angle. Rename alpha. All right. It should say alpha. I did this. Yeah, angle alpha. Okay. It shows the degrees. I guess that's okay. All right, now let's try it. Slider is here. Angle alpha. Apply.
You have to make the slider random instead of fixed.
Oh. Can I do that now, or do I need to start again?
I guess you can double click the slider and try to change its properties.
Oh.
Yeah, you can do it in the properties.
Oh.
Whenever you change the properties.
So, I see, right. So I have to make it random. Not fixed. Is that right?
Yeah.
Still not.
And then you have to rotate the segment by angle alpha.
Where?
Go back and when you're actually rotating the segment.
Oh.
Yeah.
Oh, the rotation. This one here.
Yeah.
So I have to pick. The object, the center point. Yeah.
And now if you move the slider, it should work. Oh, okay.
All right.
It's working. It's working on mine. It's
Okay.
working on mine.
Can you share your screen on Adobe Connect?
Oh.
Since I messed up, I'm going to go to. did it so smoothly yesterday. So there you go. That's good. Give you a chance. Can you share?
Yeah, I'm trying to.
Okay.
Oh.
Oh, do I need to make you?
I don't think there's enough time.
There's not enough time. You're right. Okay. All right. So starting next time, if you can show us that, I think I have to make you a. I have to make the collaboration correct and make you look around and all that stuff. Okay. So for next time, let's try to log in. To log in on both and sort of get set. Okay. By the time it starts, so we don't waste any time.
Okay.
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 You all
Yeah.
set?
Okay.
All right. Ryan and Logan, send me an email today.
Got
Will
it.
do.
Okay. All right. Have a good day.
You too.
Thank you.
Me too.